Hello everybody and welcome to Blockchain Expert. In this video, I'll be showing you how to build an NFT auction. We'll be writing the contract that allows us to auction any NFT at any time for any duration of time, and we will be writing a front end to interact with that contract as well as some automated tests. Now, to actually create an ERC-721 token, we're going to do exactly what we did in the previous project. So if you haven't yet watched that, please watch through, because in this video here, I'm not going to walk you through the steps kind of as in depth as we did in the previous project. Anyways, with that said, let's go ahead and get started. The first thing we need to do is pretty much, again, what we did in the last project, which is set up our Minty token or our Minty contract. And then once we have that, we will write the auction contract because, of course, to build an auction NFT, we have to first have an NFT to auction. So what I'm going to do is go to my terminal here. I'm in VS Code in a new folder, and I'm going to run the command git clone and then this URL right here, which is the URL to this Minty repository. Okay, so I'm going to go ahead and hit enter here. It's going to clone Minty. Now I'm going to cd into Minty. I'm going to type npm link. And once this is finished, I'm going to type npm install like so. All right, so now that the dependencies are installed, we're going to go into this Minty directory here. We're going to go to contracts, and we're actually going to create a new contract. So we will be deploying this Minty contract, but before we do that, we're going to write the auction contract, and then we're going to have the auction and the Minty contract deployed at the same time. So I'm going to create a new file here, and I'm going to call this auction.sol. All right, inside of here, we're going to write our pragma line. Now, this pragma line actually needs to be the same as our contract line, so I'm going to copy this pragma line here and paste it in. Okay. Next, I'm going to import the interface for ERC-721 from the OpenZeppelin contracts, because we're going to need that to understand, or to, I guess, represent what NFT it is that we're auctioning for each individual auction. Because this contract, we're going to set it up so that it can have multiple NFTs being auctioned at the same time, and it doesn't matter which tokens they are. It could be any contract. So I'm going to say import, and then this is going to be at Open Zeppelin, and then /contracts /token /ERC-721, and then /IERC-721.sol. Okay, so that's the first one that we want. Next, we are going to import the IRC-721, and then this is going to be the receiver. Now recall that, as I showed you in the previous project, when we write a smart contract that can receive an ERC-721 token, we have to implement a special method, and that special method is going to be kind of represented by this. So obviously we'll do that in a second, and you'll see kind of what we need to return and how we set up that method. But that's why I'm importing this other interface. Okay, now we're going to write our actual contract. So we're going to say contract auction. So before I dive into this auction, let's understand what we actually need as part of this auction. Well, we're going to need kind of a listing or an individual auction, right? So I'm calling this auction, but really this contract represents multiple auctions. So we need some kind of listing, which is whatever auction is going on or whatever auctions are going on. We then need some way to actually make a bid. And we need to determine when this auction is finished and allow someone to withdraw the NFT that they have actually won, and for the owner of the auction, or the person who created it, to withdraw the funds that they received from the auction. Now, another important aspect here is that if someone makes a bid and they are outbid, they need to be able to withdraw that bid, right? If you didn't win the auction, then any money you send to the contract, you should be able to get out. So that's the basic idea here. So let's start by creating our data structures, mapping types, all of that kind of stuff, our different events, and then we can write our functions. Okay, so I'm going to start with a struct here for our listing. Now, since we can be listing any type of NFT, we need to have here IERC-721 and then NFT. And this is going to represent the NFT contract for whatever this listing is. Next, we're going to need to know what the ID of this NFT is. So we're going to say uint NFT ID. And we're going to need to know what the minimum price is, or kind of the starting price for this auction. So I'm going to say uint and then min price. Next, we need to know what the highest bid currently is, as well as who the highest bidder is for this listing. So we're going to say uint highest bid, and then we're going to say address highest bidder. Okay. Next, we need to know what the end time is for this auction, so when it expires. So I'm going to say uint end time, and then we need to know who the owner or lister of this item is. So I'm going to say address and then owner. All right, now that we have that, we need to create a mapping type that's going to allow us to store all of these listings. So I'm going to say mapping, and I'm going to go uint to, and then this is going to be a listing, and we will call this listings. And before that, I'm going to create a uint, which is the next listing ID. And this is going to represent what the next ID is for each of our listings, right? So that's kind of what will be here, IDs mapping to listings like we've had in previous projects. Okay, next, we're going to create another mapping type here, which is going to be from an address to a uint. And this is going to store the balances of different addresses, essentially how much money they can withdraw from the smart contract. Now let me actually close this terminal down because we don't need this. Okay, now that we've done that, what we want to do is write the different events that this smart contract will emit. Now really all we need is the bid and the list event. And if we wanted to, we could have an event for like auction being finished, but I don't think that's actually necessary. So for now, we're going to say event bid. And what do we want to have for our bid event? Well, we want to have an address. This can be indexed, which is our bidder, so whoever made the bid. We're going to have a uint, and this will be the listing ID. We're going to have a uint amount, which is how much this person bid on this item. And then we're going to have uint, and this is going to be timestamp. Now that I think of it, this can probably be indexed as well. Okay, so that is it for bid. Next, we're going to have an event for list. And really, I'll put the list event first just to be consistent with where I've defined my listing. So I'm going to say event list. And then here I'm going to say address, indexed, and then lister. I'm going to say address, indexed, and then this is going to be the NFT. I'm going to say address, indexed. This is going to be the NFT ID. I'm going to have a uint listing ID, a uint minimum price, a uint end time, and then a uint timestamp. Now let me just save this so we get our auto formatting. So that is quite a bit of stuff that we need here, but really that's just kind of replicating everything we had inside of this struct. We need all that information in our list event so that anytime a new listing is made, any clients that are listening to the smart contract for this event get all the information they need about the listing. They know the listing ID, they know who made it, they know what the NFT is, what the NFT ID is, etc. Okay, now that we have all of our events and data structures, I'm going to write a modifier that we're going to use quite a bit here, which is going to be listing exists. So for us to be able to do anything, say like bidding on a listing, we need to make sure that listing exists, hence why I'm going to write this modifier. So here we're going to take in a uint listing ID, and we are simply going to require that listings at the listing ID dot owner does not equal the 0 address. If that's the case, then the listing exists. Otherwise, it does not. So I'm going to say listing does not exist. And then I'm going to call our underlying function with our underscore. All right, so now that we've done that, we're going to write this kind of fancy function that we require on this contract to be able to receive any ERC-721 tokens. Now, I won't lie to you, this is going to look a little bit cryptic. It's actually very unintuitive and doesn't make a ton of sense at first glance, but the ERC-721 protocol indicates that we need to have this function and we need to return a very specific value. So what I'm going to do is refer you to the ERC-721 documentation as well as just that protocol in general if you want to read more about why we need this function and how it works. For now, just understand that it's part of the protocol. We have to have it on this contract, and you don't really need to know much more than that. So what I'm going to do here is say function on ERC, and then this is going to be 721 received. And it's very important that you spell the function exactly like this. The signature of this function needs to be identical to what I'm writing here. Then I'm going to say address operator. I'm going to say address from. I'm going to say uint and then token ID. And then I'm going to say bytes call data, and then data. And then I'm going to make this a public view that returns the bytes for type. Okay. Now what we're going to return here is ERC 721 receiver dot on ERC 721 received dot selector. Again, you don't have to worry too much about exactly what this is doing or why we need this. Just put it here, have it as a part of your contract, sorry, and this will ensure that we are able to receive ERC 721 tokens. Okay, now that we have that, we can start writing some functions that make a little bit more sense. The first function that probably makes sense to write here is our listing function. So to list an NFT, what we need access to is the NFT, the ID of that NFT. So we need like the NFT contract and then the ID. We need the minimum price, and we need the number of hours or number of days or whatever duration of time that we want to list this NFT for. Now, just like our ERC20 tokens, what the user is going to have to do is give this contract approval to transfer the ERC 721 token to itself. So the way we list or kind of perform an auction is we take the ERC 721 token from the user. They first approve us to transfer it. We then transfer it to this contract and hold it in the contract. We have all of the bids go on, blah, 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 everything happens. And then as soon as someone wins, we can transfer them that NFT and then transfer the owner their money. Now, if no one bids on this auction, then what we can do is just give the owner back their NFT. We can allow them to withdraw that. All right. So let's create this function. We're going to say function list. We're going to take address NFT. We're going to take uint NFT ID. We're going to take in uint, and then this can be min price. And then we're going to take uint like this, num hours. Now, actually, we're going to change this from address to be ERC 721, just like we have right here. All right, so now that we have that, the first thing we need to do is make sure that the person who is trying to list this NFT actually owns the NFT. So the way we can do this is we can say require, and then this will be, what are we calling this? NFT dot owner of, and then this will be the NFT ID is equal to the message dot sender. And we can say you do not own this NFT. Okay, next we can say require, and we need to make sure that we actually have approval to transfer this NFT. So I'm going to say NFT dot and then get approved, and this is going to be NFT ID equals address of this, and I'm going to say this contract is not approved to access this NFT. Okay, perfect. So the way that this function works is it tells us what address is approved to access this NFT. You can only have, I believe, one operator at a time or one address able to do this. So this is telling us if the address that's approved to access this NFT is us. Great, that's all we need. Now that we know that we have access to the NFT and that the owner does not, or the owner does, sorry, own the NFT, what we can do is transfer the NFT to ourselves. So we can say NFT.safe transfer, and then this is going to be from. We're going to transfer from the message.sender to ourself. And what NFT are we going to transfer? Well, we're going to transfer the NFT with the NFT ID. Now that we have performed that transfer, what we are going to do is essentially fill out all the fields we need for our listing to essentially create a new listing. So we are going to go here and we are going to say listing storage listing is equal to listings at the next listing ID. And then we're going to start filling in the fields. So we're going to say listing.nft is equal to NFT. We're going to say listing.nft ID is equal to NFT ID. We're going to say listing.minimum price is equal to the minimum price. We're going to say listing.end time is equal to the current block.timestamp plus, and then this is going to be the number of hours. So this is num hours here, multiplied by 1 hours. All right, so just to quickly explain this here, we are taking the number of hours, which is going to be the number of hours we want to run this auction for. Now, you can make this number of minutes, number of seconds, number of whatever, and then you can just adjust this to be that, right? You could also just take a timestamp and then make the listing end time be equal to that timestamp, but you would have to ensure that that timestamp was above this timestamp. Otherwise, the auction would just end immediately, right? Okay, so that's what we're doing here. Block.timestamp plus whatever this duration is. Then we are going to assign the owner. So we're going to say listing.owner is equal to message.sender. And we're going to say listing.highestBidder is equal to message.sender. Now, the reason I'm doing this is because the way that I'm going to allow people to withdraw the NFT, like kind of claim the NFT, is by checking who the highest bidder of the NFT is when the NFT auction ends. So what that means is that if no one was to bid on this NFT, then the owner, or like kind of the winner, would just be the message.sender, who is the person who kind of auctioned off this NFT. Hopefully that makes a bit of sense, but this is going to allow them to kind of claim it if no one bid on it. All right, so now we are going to emit our listing event. So I'm going to say emit, and this is actually just going to be the list. Yeah, this should work because that has a capital L and this is a lowercase l, okay? And we're going to say message.sender, NFT, NFT ID, next listing ID, minimum price, listing.endtime, and the block.timestamp that this occurred at. And just to make sure that this is going to work as we expect, I'm going to go to this event here, and I'm going to change NFT to be IERC 720. All right, so that's good for our list event. Now I'm going to say my next listing ID plus plus. Make sure you don't forget that so that we don't override an existing listing. And there we go. We have now created the list function. Now that we have the list function, we need a way to bid, and then we will need a way to kind of end and withdraw our funds. So I'm going to say function bid. This will be an external payable function. And what this function needs to take is the listing ID that we want to bid on. And then the bidding amount will be the amount that we send to this function. So I'm going to say uint listing ID, and I'm going to put my modifier here of listing exists, and then this will be for the listing ID. Okay, so that is it for bid. Now, inside of bid, the first thing we need to do is make sure that the price that we're kind of paying here, right? So the amount that we're sending to this function, which will represent our bid, is larger than the minimum price, as well as larger than the highest bid currently. We'll also need to make sure that this auction is not finished. So there's kind of three things we need to check here. So I'm going to say listing storage listing is equal to listings at listing ID. I'm then going to say require that the message.value is greater than or equal to the listing.minimum price. All right, so this is the first thing that I'm checking, because assuming that no one else has bid on this, we're only going to allow you to bid if you pass a value greater than the minimum price. I think that makes sense. And then for our message here, we will say you must bid at least the min price. Okay, so that is our first require. Our next require is that the message.value is greater than, and strictly greater than, not greater than or equal to, the listing.highest bid. Okay, and we're going to say you must bid higher than the current highest bid. Okay, and then lastly, we're going to make sure the auction is not finished. So we're going to say that block.timestamp is less than the listing dot end time, and I'm going to say auction is over. Okay, so that is our three preconditions that we need to check. Now that we've done that, we know that this user can actually make this bid. So the first thing we need to do is we need to take whatever the current bid was, and we need to allow the user who made that bid to withdraw that bid. So we're going to say balances, and this is going to be at listing dot highest bidder is equal to, or not equal to, plus equal to, very important to do plus equal here, listing dot highest bid. Now, the reason I'm saying it's important to do plus equals is because there could be multiple bids. So we don't want to be wiping out previous bids that they could be withdrawing. So we need to add to the balance whatever it was that now they can claim, right? Okay, so that's what we have for that. Then we're going to adjust the highest bid and the highest bidder. So we're going to say listing.highest bid is equal to the message.value. And we're going to say the listing.highest bidder is equal to the message.sender. And then we're going to emit our bid event. Now, who made this bid? That is message.sender. This was made on our listing ID with the message.value at the block.timestamp. Okay, that is our bid function. Now that we have our bid function, we're going to write a function that allows users to withdraw any of their funds. And what this will do is just withdraw all of it to them. So we're going to say function withdraw funds. This will be external. And we're going to say uint balance is equal to balances at the message.sender. We are going to say balances at the message.sender is equal to 0. And then we're going to send them their funds. So we're going to say bool sent. And then this is going to be equal to payable message.sender.call. Okay. And for the value, this is going to be the balance. And we'll put our empty string. Then we will require that this was successful and all is good. Okay, so that is withdraw funds. Now that we have withdraw funds, the last thing that I want to do is just write a function that gives us information about a specific listing. So we can know, for example, what the address of the NFT is, what the NFT ID is, what the highest bid is, the minimum price, etc. So what I'm going to do here is say function get listing. I'm going to say uint listing ID, and this will be a public view that returns, and we are going to return an address, a uint value, another uint value, another uint value, and another uint value. Now I'll tell you what those are in a second, but those are the values we're going to return. And before we do that, I am just going to say listing exists here, and then listing ID, because we don't want to be returning a listing that doesn't exist. All right, now we will simply return, and we're going to return an address of listings at listing ID dot NFT. So we're returning the NFT address. Then we're going to return listings at listing ID dot NFT ID. So this is the NFT that they are bidding on. And then we are going to return the highest bid, the minimum price. So we're going to say dot min price. Actually, before we do that, we should probably return what the highest, actually, no, we don't need to know who the highest bidder is. We just want to know the minimum price, so I'll leave it like that. And then I'm going to say listings, listing ID dot end time. Okay, and we'll put our semicolon here, and I think that's all we need for this function. So again, we're returning the address of the NFT contract, the ID of the NFT that's listed, the current highest bid, the minimum price, and the ending time for this listing. Okay, with that said, that's pretty much going to wrap up this smart contract. So let's quickly go through it and make sure everything is clear. Also, I'm getting an error here. It's saying Pragma Solidity requires a different compiler version. That's actually fine for right now based on how Minty is going to work. Okay, so we have our struct for our listing, where again, we take the NFT contract, ID, minimum price, highest bid. You guys could read these yourself. We have our mappings for listings and for balances, and we have our events. We have the modifier if the listing exists, and this function that allows us to accept an ERC721 token. To be able to list something, we need to provide the address of an ERC721 compliant token contract, the NFT ID we want to list, the minimum price, and the number of hours. To be able to list this, the owner must own the NFT, and they must give our contract approval to transfer the NFT. All right, so now that we have written this function, actually the last function that we need to write, which probably I should have written before, is called end. Now, end is a function that anybody can call to end the listing and transfer the NFT to the owner. So I'm going to say function end, and this is going to be uint listing ID. This is going to be external, and this is going to be listing exist. So listing exists like that. Here we're going to pass the listing ID, and we're not going to return anything. Okay, now I'm going to say listing storage listing is equal to listings at the listing ID. And I'm going to make sure that to be able to call this function, the listing actually has to be finished, right? So I'm going to require that the block.timestamp is greater than the listing.endTime. And I'm going to say, otherwise auction is not over. All right, again, what we're going to do in here is we're going to essentially end the auction if it's finished. And the way we end that is we give whoever the owner of the auction was the highest bidding amount, so they can withdraw that. And then we transfer the NFT to whoever the winner of the auction was, whoever had the highest bid. So I'm going to say balances of listing dot owner, and this is going to be plus equal to listing dot highest bid. Then I'm going to say my listing dot NFT dot safe transfer from, and I'm going to safe transfer from this address, the contract, to the listing dot highest bidder, and the NFT I'm going to transfer is listing dot NFT ID. Okay, then I'm going to say down here my listing dot owner is equal to address 0. The reason I'm going to do this is so that now we will not be able to call any of the functions that have this listing exists modifier, because if we go to listing exists, let's have a look at this modifier here, it makes sure the address is not equal to 0. So I'm essentially deleting the listing by writing this. I also could just say delete and then listings at listing ID. However, I may want to preserve some of that information, although now that I think of it, it's probably fine to just delete this. So let's actually just delete the listing, and that will then reset the address to be 0. Okay, so that looks good to me. Now that we have this, we are done with the smart contract. Okay, so what we want to do now is we want to write a test for this smart contract to make sure everything is working. This is especially important when we're doing something like collecting people's NFTs. Once we write that test, we will then deploy this contract as well as our Minty contract here for the actual NFT. We can mint some NFTs, and then we can write a front end to interact with the contract and actually have a fully featured auction. All right, so let's go to test here. Let's open up our sample test, and let's change the name of this sample test to say auction.js. Okay, now inside of here, we can delete pretty much everything that we have. And rather than greeter, this is going to be testing the auction contract. Inside of here, we're going to define a few global variables that we want. We're going to say let auction. We're going to say let minty. We're going to say let owner, and then let ADDR1 and let ADDR2. Now, just like we did in some of the previous projects, we're going to write a before block here that will run before all of our test cases one time. I'm going to say async, and inside of here, we're going to say owner, ADDR1, ADDR2 is equal to await ethers.get signers. And then we are going to deploy the Minty and the auction contract. Now we need both of them because the Minty contract is going to be our NFT contract, and we can't test the auction contract unless we have an NFT to auction. So I'm going to say const Minty is equal to await ethers.get contract factory, and this is going to be Minty. Then I'm going to say Minty is equal to await Minty.deploy, and I need to pass a name and a symbol. So I'm going to say name, and for the symbol, I can just do something like that. Doesn't really matter what I put here. Then I'm going to say const auction is equal to await ethers.get contract factory. This time it's going to be auction. Then I'm going to say auction is equal to await auction.deploy. There's no constructor for auction, so this is fine. Then I'm going to say await minty.deployed and await auction.deployed as well. All right, now what I'm going to do is mint a token. So I'm going to say await minty.mint token. I'll show you that function in a second, but this exists on Minty. And I'm going to mint this to the owner address with a random URI, or just, like a random string URI. We don't have to actually put an IPFS URL here. It's not going to matter if we have that or not. Okay, so this is kind of the deploy aspect of our Minty and auction contract. If we go to Minty here, let's get out of node modules. You can see we have this mint token function. Notice that we can call this mint token function from any address. There's no access control here. So obviously you would probably want to add some access control, but I'm just going to leave this ungated and let you guys do as you please in terms of minting the tokens. Okay, now that we've set that up, we are going to write our different describe blocks for what it is that we need to test. So I'm going to say describe. The first thing I want to test is probably listing. The next thing that I want to be testing is bidding. Okay, and then what else do I want to test? I want to test withdrawing funds. So we're going to say withdraw funds, and we need a way to actually end the auction as well. So we're going to say describe end like that. All right, I think that's all we need for our kind of main categories of tests. Now let's go into our describe block here and start testing actually creating a listing. So I'm going to say it. And then this will be revert if not approved to list. We should actually probably write should revert. So I'm going to say should revert if not approved to list. Say async. And I think this test is pretty straightforward, but we want the, this function to revert if we try to list a token that we do not own. Okay, so I'm going to say await and then expect. And then this is going to be auction.list. Okay, and then I'm going to do minty dot address 1, 10, and 1 dot 2 dot b, and then reverted. Okay, now just explaining this, this is the address of our NFT contract. This is the ID of the NFT, which always starts at 1, by the way. It doesn't start at 0, it starts at 1. Then 10, this is going to be the minimum price. And then 1, that's going to be 1 hour that we want this, auction to last for. Now, we do own this NFT because we're calling this by default from the owner, which we put here. However, we have not approved the contract to send it, hence why this is not going to work. Okay, so now that we've done that, let's copy this. And we're going to do another kind of failing test case here. Should revert if not owner of NFT. And this time I'm going to say auction.connect ADR1, and same thing, this should fail. All right, next we're going to say it should allow listing an NFT, and I'm going to say async here. And now I'm going to approve this NFT or approve my contract to transfer the NFT and then try to list it. So I'm going to say await minty.approve, and I'm going to approve the auction.address to transfer token 1. Then I'm going to say await expect auction.list, which by default will be called by the owner. Again, we can pass our minty.address 1, 10, and 1. You can really pass any values here. You just have to make sure these two are correct. And then we're going to say .2 .emit, and we're going to test that this emits an event. So I want this to emit an event from the auction contract, and this event should be list. You can also check the arguments that are emitted, but in this case, it's fine to just check that the list event was emitted. Okay, so that's going to be this test case. Now I'm going to copy this, and I'm going to make sure this allows me to list a second NFT. So should allow listing second NFT. Okay, so I'm going to say await minty.mint token. I'm going to mint another token to the owner.address, and we'll call this URI2. So now the token here that will be minted is token with ID 2. So now I'm going to approve the contract to transfer token with ID 2. And then I'm going to list token with ID 2. And this time I'll make a minimum price of 100. Okay, perfect. So that looks good to me. And now we should have all of our tests for listing. So we can actually try this out and make sure it's working so far. So I'm going to run npx hard hat test. Notice that I'm inside of the Minty directory. Okay, so let's run this. All right, so I got an error here. It looks like I spelt balances incorrectly in my contract. So let's go here and yes, let's fix balances so that this is now spelled correctly. Let's go and run this again and see if this test is going to pass. Okay, we got another issue here. It says invalid type for argument and function call, invalid implicit conversion from contract I ERC 721 to address requested. All right, so let's go and fix this. And the way we're going to fix this is we're going to go to our list and we're going to change this to say address. Now what we're going to do is we're going to come here. We're going to say I ERC 721. We're going to say NFT contract is equal to, and then we're going to wrap our address I ERC 721 as an NFT. Now, the reason we're getting this error is that we are submitting an address to this list function. And the way that we submit it, it cannot be certain that this address adheres to the IRE 721 protocol. So what we need to do is explicitly convert it using this syntax. I know it seems a bit weird, but this is how we have to fix that. So now, essentially anywhere where we wrote NFT, we're going to replace this with NFT contract. Okay, so NFT contract is safe transfer from, listing.nft is equal to, and then this is going to be NFT contract. And let's see if there's anywhere else. I think this should be fine. And actually here, we can leave this as NFT because if we go to our event, we can see that this is an address for the NFT, not an IERC 721 interface. So it's fine to leave that as is. Okay, it looks like we might have some other errors as well, but let's save this contract and rerun and see if that fixed any of them for us. All right, so it looks like we have two errors here. One saying that the function list does not have any access or visibility modifier. Okay, so let's add the external visibility modifier. That's an easy one. And then it says here that NFT ID has the invalid type for argument in function call. And that is coming from line 83. Okay, let me run this one more time just so we isolate this individual error. And let's see what's wrong here. Okay, so let's go to line 83. NFT ID says this needs to be, okay, so this is the issue here. We need to change in our event this to be a uint, not to be an address, because, well, the NFT ID is not an address. So just a silly mistake there. Let's clear, let's rerun, and let's see if that fixes our problems. All right, so we just ran into a few warnings and another error here. Apologies, but this, of course, is why we test the contract. First of all, we need to remove this view keyword from on ERC 721 received. That was just kind of a habit of mine to write this view. We don't need that. It's not a view function. It will just be public. Okay. Now we're also getting an error inside of our test script that says ether.getSigners is not defined. And that's because this needs to be getSigners. Okay. Let's clear and run this again. And fingers crossed, we should be good to go now. All right, so after running, we got another error here. Now, this error is occurring because we forgot to run our hard hat node. Now, the reason why we need to run the hard hat node is because the testing for this specific contract works a little bit differently than it did for some of the other contracts that we had, and we just need to have this hard hat node running in the background. So I'm going to type npx hard hat node and run that in my terminal so that now hopefully this will work. Now I'm going to start another terminal. All right, so now we're going to run our test, but I need to first cd into the Minty directory. Then I can type npx hard hat test. And now this should run our contract. And let's see if we pass our test. Okay, great. And if we go here, we can see that it does all of these contract calls on our, what do you call this here, hard hat node. All right, so that is all working as expected. Now that we have the listing test done, let's do our bidding tests. Okay, so for bid, what do we need to test here? Well, there's a few fail tests, right? We should not be able to bid if it's less than the minimum price. We can't bid on an auction that doesn't exist. We can't bid under whatever the current highest bid price is. It's actually quite a bit of stuff to test here. So let's start. I'm going to say it should not allow bid below min price. Okay, now this will be an async function. And here I'm going to say await expect auction dot connect addr1 dot bid. I'm going to bid on auction ID 0. I know that that's the one that's going to exist. And the reason that's the case is we already deployed or already listed 2 different auctions here. And this before block only runs one single time before all of our tests. So these should still be existing, right? So we're going to bid 0 and we're going to pass here the value. And for the value, we will pass, let's say 9. Okay, so 1 less than the minimum price. Then I'm going to expect that this will be reverted. Okay, now let's copy this. And we're going to say it should not allow bid on auction that doesn't exist. So let's do this. Okay, and now for the ID, let's just go with something like 9, which we know doesn't exist. And we can go with even a very large value. And again, this should be reverted. Okay, after that, let's make it so that we actually can have a valid bid. So we're going to say it should allow valid bid. Okay, so we're going to go here for async. And what we're going to do is say await expect auction.connect addr1.bid. We'll bid on auction with ID 0. And for the value, we can pass, say, 15, so 5 larger than the minimum price. Then we can go here, and we can expect this .to emit, and we want the auction contract to emit the bid event. Okay, then if we want to make sure that all of our listing information was actually updated, we can do the following. We can say const listing is equal to await, and then this is going to be auction.get listing and then 0. And actually, to make this a bit more clear, I'm going to say const, and then I'm going to write out all of the values that are returned by this get listing function. Now, that is going to be the address of the NFT contract. So I'm going to say NFT contract, the NFT ID, the current highest bid. So we'll say highest bid, and it's going to return as well the minimum price, and then the end time, but I won't check the end time because I don't know exactly what the block timestamp was, so I don't really need to check that. Okay, so now I'm going to expect that the NFT contract .to equal, and then this should be minty.address. I'm going to expect that the NFT ID .to equal, and then this will be 1. I'm going to expect that the highest bid .to equal 15, and I will expect that the minimum price, expect min price .to equal 10. Okay, now that we have this, let's continue writing and make sure that you can't bid less now than whatever the current highest bid is. So I'll actually copy one of these test cases. I'll say should not allow bid less than, that is less than highest bid. Okay, so now let's try to bid, say, 11. We can connect with a different account too, so ADR2, and try to do this on ID with 0, so that should fail. And then, alternatively, we should actually allow a bid greater than the highest bid. Okay, so now we're going to copy this and should allow valid bid that is higher than highest bid. So now I will connect with ADR2, and I will bid on auction with ID 0, and this time I will bid with, say, 50. Okay, and we will expect this information to be the same. However, now the highest bid should be 50. Okay, so now we are almost finished. The last thing that we need to do here is actually test if we can bid on an auction that is finished, right, that has ended. Now, this is a bit more complicated because what we actually need to deal with here is kind of time-sensitive tests, right? We need to adjust the time that we are sending a kind of contract at to be, say, an hour in the future, which will be past when the auction has ended. So we want to make sure we can't bid once it has ended. Okay, so the way we're going to do this, we're going to say we're going to say should not allow bid on auction that is completed. Okay, and we're going to go async. And here we're going to say await, and this is going to be ethers.provider dot send EVM underscore mine. And what we actually need to do here is pass an array where we have await a function called getTime, which I'm going to show you how to write in 1 second. And then we're going to say plus 60 times 60, which is going to be 3,600. So I can just write this out. And this is the number of seconds that we want to advance the EVM time. Now, essentially what we're doing here is we're kind of mining an artificial block, and we're going to be setting the timestamp for this block to be an hour in the future above whatever the current block timestamp is. Now, I don't know what the current time is, so that's why I'm going to have a function that gives me what the current block timestamp is. And what this does is advance the EVM so that now we are kind of an hour in the future, or we're at whatever this block timestamp is that we're kind of mining. Okay, so let's write a function. We'll do it actually above here. I'm going to call this const get time. And this is going to be an async function. And this is going to return whatever the current block timestamp is. Now to get that, I'm going to say const block num before is equal to await providers. This is going to be ethers, sorry, dot provider dot get block number. And now that I know what the current block number is, I'm going to say const, and this will be block before is equal to await ethers dot provider dot get block, and then I'm going to get the block number before. Now the reason I'm calling this before is because this is going to be the block before the new block that we mine, so that's kind of why I'm naming it this. And then I'm going to return the block dot, so the block before dot timestamp. Okay, so this is how you get access to the kind of current block based on the hard hat node that is running. And then once you have the block, you can get the timestamp. So first you need to know the block number. Once you know the block number, you can get the block information, and then you can return any information you want, like the timestamp. Okay, so let's go here now, and this getTime function should be working. Now that we have advanced the kind of EVM here, we need to actually make a bid, right? So we're going to say await expect, and then this is going to be auction. We can connect here with, say, ADDR1 dot bid 0. Let's pass a really large value to make sure that's the reason, or not the reason why we're failing. Then we're going to say .2 .b reverted. Okay, so this should be working. Now, the reason this should work is when we get this block and we advance the time an hour, that means that this auction should be done by then, right? Now, if we look at when we created the auction, we can see that we specified that it should last 1 hour. So that's why that's the case. Okay, so let's test this now and see if this is working. So npx hard hat test. Okay, so it passed listing, and we got an issue here. What is the issue? Should not allow BIF on auction that is complete. Okay, so first of all, let's change that to bid. And it's telling us that expect is not a function. Oh, reverted is not a function. That's the issue. I put my parentheses here when we don't need those. So let's remove those and rerun it and make sure that this works. And there we go. We are passing all of our tests. Okay, so now at this point, remember, we're maintaining the same contract state because of that before statement. We have auctions that have finished. Now, one of the auctions finished with bids on it, and the other auction finished without bids on it. So we want to test, first of all, that users can withdraw any bids that they've submitted that didn't win the auction. And then we're going to want to test that whoever the kind of current owner of the NFT is, whoever won it, or whoever was the person who created the auction with this NFT, if it didn't have any bids on it, can now get their NFTs. Okay, so let's go withdraw funds. Inside of withdraw funds, the first thing we'll write is it, and we'll say previous bidders can withdraw their funds. Okay, now we'll say async, and we're going to say await, and this is going to be expect, if we can type this correctly. Okay, let's just rewrite this. That was pretty bad. Okay, so await, expect, and then this is going to be auction dot connect ADDR1 dot withdraw funds, and then I'm going to say .2 dot change, and then this is going to be ether balances like that. And for our addresses, we're going to have ADDR1 auction, and then this is going to be 15 and -15. Now, let's just have a look here to see why I'm doing this. So remember, our first valid bid was by ADDR1. They bid 15, and then someone outbid them with 50. So I want them to be able to withdraw the 15 that they bid. So 15 should go to ADDR1 and -15 from auction. Okay, so that's all we need, I think, for that. So let's save that. Let's copy this. And now let's make sure that the current bidder cannot withdraw their funds. So I want to make sure whoever's currently winning the auction can't withdraw that. So I'm going to say current highest bidder cannot withdraw their funds. And we'll just change this to be 0, 0. We'll change this to be ADDR2 and ADDR2. And I'm just going to ensure that no funds are transferred when address 2, which is the current winner of our listing with ID 0, is trying to withdraw their funds. Okay, so that's that. And then we are going to do one more thing here that makes sure that the owner of the auction cannot withdraw their funds until the auction is completed, right? So since the auction end function has not yet been called, that means that the owner cannot take their prize yet because the NFT hasn't yet been transferred. So we're going to write that in. We're going to say owner cannot withdraw their funds until end is called. And then we can change this to just say owner, and verify that that works. All right, so let's test this and see if this is working. Okay, and we got an issue here. It says txResponse.wait is not a function. Okay, so I believe the error here is that actually what we need to do is put in a wait inside of this withdraw funds call. Now, I know this seems a little bit weird, but we need to essentially await this to be completed and then await checking the ether balances. So let's just try this and actually check and see if this works. Okay, npx hard hat test. And there we go. Okay, now we're passing all of the tests. So something's going on where when we are checking the change in ether balances, we haven't yet kind of completed this function. So we're awaiting this check, but this function hasn't yet finished, hence why it was failing. So that's probably why we need to do this kind of double await thing, even though it looks a little bit weird. Now that we have done this, we want to check our end function. Okay, so we're going to say it, then we're going to say cannot call end if auction is not completed. So the way we're actually going to test this is we're going to go to where we created our second listing. So that is right here. And we're going to change the time duration to be 2 hours so that when we move the EVM ahead by 1 hour, only one of our auctions is finished. So that now for this test, we can check and make sure we can't call end on the auction that's not finished. Okay, so I've made that change. Now we're going to come here and I'm going to say await, expect auction.end, and we're going to try to end auction with ID 1, which is the second auction. We're going to expect this .to be reverted. Okay, we'll do another one here. Now we're going to make sure we can call the end function when a auction is completed. So we're going to say can call end on finished listing, and then we'll also just make a note here that this should transfer the NFT. Okay, so let's go here. And now I'm going to say await auction.end 0. And I'm going to expect that the Minty, so we're using the Minty contract now, .owner of 1 is going to be changed. So this is going to equal ADDR2.address after I call this. So previously it would have been the contract itself. Now, after I call the end function, which should work on this listing, that it transfers this token. Okay, now that we've done that, we want to make sure we cannot call this 2 times. So I'm actually going to copy this here. I'm going to say cannot call end twice. The reason it's important to check this is because if you called end twice, then you would be giving the kind of owner of the auction their winnings 2 times, which obviously is an exploit. So we're going to say cannot call end twice, and then we're going to await that this called with 0 is reverted. And then we're going to write another one here that checks if the owner of the contract can withdraw their funds. Or sorry, not the owner of the contract, the owner of the auction. So I'm going to say listing owner can withdraw funds once the auction is done. And then we'll make this async. And we'll go here and we'll say await, expect, await, auction.connect, owner.withdraw funds. I'm just doing this to be explicit here. We don't really need to add connect, but just to make it very clear. And then I'm going to say .to .change ether balances. And then this will be owner, auction, and then they should be receiving 50. So it's going to be 50 and -50. Okay, and then lastly, I want to make sure that whoever won the auction cannot withdraw whatever they submitted as like kind of their bid for the auction. So actually, I'll copy this. I'll put this here, and I will say that the auction winner cannot withdraw funds once the auction is done. So we'll change this to be 0 and 0. Now the winner was ADDR2, so we'll put ADDR2 here and ADDR2, and we'll do this before we do this to make sure that even if the smart contract had sufficient balance, they would not be able to withdraw that. All right, so let's move this up now, and let's test, and let's see if this is working, and we pass all of our tests. Now, there is probably a few more tests that we could write here, but I think that this is going to be decent enough coverage to be confident that this smart contract auction is working. Please feel free to test this more, add additional test cases, add multiple auctions, multiple listings. You can do whatever you want here with the testing, but I think that this is going to be good enough for our use case. Now that we have our testing done, our auction is finished. The next thing we want to do is deploy our contracts by writing the deploy script. Then we want to write our front end and interact with them. All right, so as I was saying, let's dive into our deploy script here, which is going to be an SRC. And we don't really need to do much. We just need to make it so that now we're going to deploy the auction contract as well as the Minty contract. So let's actually get rid of some of these console.logs. We don't really need these right now. And let's grab our auction contract. So const auction is equal to await hardhat .ethers.get contract factory, and then this time we'll just hard code in auction. Next, we can say const auction is equal to await auction.deploy, and that's all we need. And then we're going to say await auction.deployed. Now here we're just going to make a slight modification to the deployment info function. So you can see here that it's returning deployment info. What I want to do is make a function here. This is a function we've used a few times, but I want to kind of alter it a bit. I want to say async function write deployment info. I'm going to take in my contract and my file name, and I'm just going to make the file name equal to an empty string here as default. And I'm going to say const data is equal to, and then this is going to be contract. Inside of here, we're going to say address. This is going to be contract.address. I'm going to say the signer address is the contract.signer.address. Then I'm going to say the ABI, which is probably the most important thing here, is contract.interface.format. Let's just fix this so this is spelled correctly. And then we're going to say const content is equal to json.stringify. And we're going to stringify the data with null and 2 spaces. And then we're going to await fs.writeFile. We're going to write to the file name, the content, with the encoding of UTF-8. Okay. So now, rather than returning deployment info, or maybe not rather, but additional to returning the deployment info, we're going to say await and then write deployment info. We're going to pass the auction contract, and then for the file name, we'll say auction.js. So now we're not actually kind of altering what the default behavior of this script is doing by returning the deployment info. Instead, we are just making it so we are also going to write our deployment info for the new contract we're deploying, which is the auction contract. Okay, so now we can test if this deploy script works. Now, the way to do that is to start by running our hardhat node. Now, this might actually already be running, and it looks like it is running. So I'm actually just going to shut it off and rerun it. And then once this is running, I'm going to go back here and I'm going to type Minty deploy, and this should automatically run this deploy script for me. Okay, so let's see if this works. And we can see now that we have our auction.js file. A bit of an issue here in terms of the formatting. I'm not sure why we're getting this. Okay, that's fine. Oh, it's because I did JS, not JSON. Okay, we'll fix that in a second. And then we have minty deployment.json. So let's quickly go to our deploy, and let's make sure this says JSON, and then let's actually rerun this here. Okay, do we want to override this file? Yes, we can override that. That's fine. And now we should have auction.json, and this looks better. Okay, so now that we have deployed that, let's start working on our front end. So I'm going to close this Minty directory, and I'm going to create a new directory called front end. Now, as always, we're going to create our base.html file and our script.js file. Now, I know at this point you guys probably have this memorized, but of course I'm going to walk through it as always. Let's create our HTML5 template. And for the name here, let's call this NFT Auction. All right, so let's bring in our script tags like usual into the bottom of our body. Okay, so I'm going to place those inside of here. And let's start writing out what it is that we need for our auction. So we're going to use the same classes that we've used before. So actually, I'll just copy in the styling as well, because we've seen this in all of the other contracts, or all of the other projects, sorry. So let's paste those in. Okay, we have our container, our row, and our item. Feel free to pause and copy that out if you don't already have access to that code. And now we're going to start by creating a container. So we're going to say class is equal to container. Now, what do we need? Like, what are the functions that we have to have here for our front end? Well, we need a way to list an NFT. We probably want to be able to view the NFTs that we have. We want to be able to bid on an NFT. We want to be able to end the auction, and we want to be able to view information about a listing. So the first function I will implement is listing, and then I will implement the ending, and then we can go from there. Okay, so we're going to create another div here. Say class is equal to row, and then we're going to create an item. So class, or not class, div. Okay, class is equal to item. Perfect. Now inside of item, we're going to have an h3. We'll say this is list, and then we need to essentially put all of the input fields that we need to list an item. So the first thing that we need to list an NFT is the ID of that NFT. We also need the minimum price of that NFT, and we need to know the duration that we're listing it for. Now, we also need to know the address of the NFT contract, but we can kind of hard code that in ourselves because we know we're only going to be using one NFT, at least for this front end that we're writing. So I'm going to make a few input tags here. I'm going to say input type is equal to number, and let's put this inside of the quotation marks. We're going to say the ID is equal to token ID. And we're going to say placeholder is equal to token ID. And then min equals 0. Okay, we'll end that input tag. Let's write a break line just so that we separate these. And I'm going to write another input tag. We're going to say type is equal to a number. And we're going to say ID is equal to the min price, and this is going to be list. Okay, then we're going to say placeholder is equal to minimum price, and lastly, again, we'll say min is equal to 0. Okay, let's add another break line. Now we want to know the number of hours that we are listing this auction for. So we can say input, and then this can be type is equal to number, ID is equal to list duration, and placeholder is equal to duration, and then we'll just specify that this is in hours. Now, we might want to end up changing this to minutes just so that we can actually test this functionality ourselves, but for now, we can leave it at hours. That's fine. Okay, now we're going to go BR, and we'll make a button. This button will say list NFT, and we can say on click is equal to the list function. All right, so that is the first item that we want in our row. Now we're going to have another item in this row. It's going to say div class is equal to item. And this is just going to be a button that ends a specific listing. So I'm going to say input, but actually before I do that, I'm going to put an h3 tag. And I'm going to say end auction / listing. For this, we're going to say type is equal to number. We're going to say ID is equal to, this is going to be the listing ID, but we're going to specify that this is for the end, the end auction kind of button. And what do we want here? We want another placeholder equal to the listing ID and minimum equal to 0. Okay, then we'll put a button. And for this button, we will say end, and then on click can be equal to end. Great. Now we're going to have another row. So we have listing and we have ending the auction. The next thing that we probably want to be able to do is actually bid on a listing. We also need to be able to approve our auction smart contract to list a token. So you can kind of change the order you have these items in, but I'm just kind of going in a relatively random order for these different operations. So inside of this same container, I will make another row. So go here, I'll say div class equals row. Inside this row, I'm going to make another item. So div class is equal to item. And this item here is going to be to make a bid. So I'm going to say bid on listing. All right, now to bid on a listing, we need to know the listing ID and the amount that we want to bid. So let's actually copy one of our listing ID inputs here. We'll do another break line. And for the ID here, min price, that's not what we want. We want this to be listing ID, and then this will be bid. And then I'm going to say listing ID. Okay, let's copy this, put it here. Now we want to know the amount. So we'll say amount, and then we can say amount to bid. Okay, and then we can have another break line, and we can have a button. And this button can say bid. We can say on click is equal to calling the bid function. And actually, I'm going to make this say bid amount. Okay, and I think that's good for bidding. Now that we have that, let's do another div. And this item is simply going to be to approve an NFT or to approve the auction contract to transfer one of our NFTs. So again, class is equal to item, h3, approve auction. Okay. Then we're going to say here we need an input field. So I'm going to copy this input field. And rather than listing ID, this is going to be token ID. And I'll say approve. And we're going to say NFT token ID. Okay, and we'll have a break line and another button. We'll say, and here we'll say approve the transfer. And then on click will be equal to approve. Okay, that looks good for this. Now we're going to have one more row. And this row is going to give us information about a listing, and then we will be done with our HTML. So I'm going to say class, row, div, class, item. I'm going to say h3, and this will be view listing info. And then we're going to put a few paragraph tags here. So first I'm going to say NFT contract, and then this is going to be span, and we're going to say ID is equal to contract address. Now I know there's a lot of other ways we can go about doing this, but I think this is just going to be the simplest, so that's why I'm doing it. Next, we're going to say NFT ID, and then for this, we will put NFT ID. Next, we want to have whatever the current bid is. So let's put the current bid, and we can say current bid. Then we want to know what the minimum price is. So we're going to say min price. And then here, this will be the min price and I'm going to put this for view. The reason I'm putting view here is so that I can differentiate between the different min prices that I have. And then lastly, I want to have my end time. So we'll put here end time view. Okay. Next, we need a little bit of an input here to specify what listing it is that we actually want to view. So I'm going to say div, I'm going to say input, and I'm going to say type equals number. I'm going to say ID is equal to, and this is going to be the listing ID, and then view. I'm going to say min is equal to 0, and then placeholder is equal to the listing ID. Probably put this with some capitalization. And then I want to put a button. So we're going to say button. We're not doing a break line here because I actually want the button to be beside this input field. And I'm going to say view listing. And then I'm going to say on click is equal to view. And I lied to you because we're going to add one more item here, which is going to allow us to withdraw our funds from the contract. That's probably an important function, so I'm going to add that. I'm going to say class is equal to item, and I'm going to say button. We'll just make this button say withdraw funds, and then we'll say on click is equal to withdraw funds, like so. All right, that should wrap up our HTML. That was a lot, but let's run this using our live server and make sure that this looks okay. And there you go. We can see the different functions that we have. So we have listing, ending the auction. We can probably add a break line here if we want. Bidding on a listing, listing ID and amount to bid, approving the auction contract, viewing the listing info, and then withdrawing our funds. Okay, looks good to me. Now let's write our script. All right, so let's go to script.js, and we're going to start out very similarly to how we always do. We are going to say our const provider is equal to new ethers dot providers dot web 3 provider, and then this is going to be window dot ethereum to connect to MetaMask. Then we're going to say let signer, and we're going to say const our NFT ABI is equal to this. We're going to say const our NFT address. Now I'm just hard coding in an individual NFT because we only have one. However, you could make it dynamic if you want by updating the HTML. Then I'm going to say let, so let's change this to be here, NFT contract equal null. And then I'm going to go here and I'm going to say let the auction ABI equal this. I'm going to say const NFT, not NFT, so I'm getting mixed up here, address, auction address is equal to an empty string. This can actually be a constant as well. And then we can say, let the auction contract equal null. And then we'll fill that information in a second. Okay, now let's write our get access function, which is really going to be the same thing we've written a bunch of times now. I'm going to say async function, get access. I'm going to say if the NFT contract, then return. Then I'm going to say await provider dot send, and this is going to be eth underscore request accounts. Then I'm going to say my signer is equal to provider dot get my signer. Let's make sure we don't forget our empty array here as well. Then I'm going to say my NFT contract is equal to new ethers dot contract, and then this is going to be the NFT address, the NFT ABI, and the signer. Okay, next let's do our auction contract. Auction contract is equal to new ethers, not Ethereum, ethers dot contract. This will be the auction address, the auction ABI, and the signer. And that's it for get access. Okay, let's actually fill in this information now. So let's go to Minty. Let's go to auction.js. No, auction.json. We can actually delete JS. We don't need this one. Okay, so auction.json. Let's grab our address. Okay, and let's grab our ABI and paste that here. Now we can go and grab our Minty. So address, okay, let's take that and place that here and grab our ABI. Okay, perfect. Now that we have that, let's write the remainder of our functions. So we need a function to list. So I'm going to say async function list. Again, I'm going to say await get access. And then I'm going to grab the fields from my input fields or from my input tags. So I'm going to say ID is equal to document.get element by ID. This is token ID dot value. Okay, then I'm going to say const min price is equal to document.get element by ID. And this is going to be the min price. And then I believed I called this for list dot value. Then I'm going to say const duration is equal to document dot get element by ID. This will be the list duration dot value again. And now I need to actually call the function on my auction contract. So I'm going to say await auction contract dot list. The NFT address is just going to be the NFT address that we have here. Then we're going to have the ID, the minimum price, and the duration in hours. Okay, I'm going to have a dot then, and I'm going to say that this is going to alert success. And then I will have a dot catch. Let's just spell success correctly. And in the dot catch, I'm going to log whatever the error messages is. Now, what I'm going to do here is I'm actually going to check if this error object contains a data field. If it does, then I can actually alert error.data.message, which will be whatever the message is that's returned from our require statement. However, if this error object does not have a data field, then what I'm going to do is say else, and then alert just the error itself. We can be getting different types of errors, one that has this data field, one that doesn't. So if we have the data field, we'll use it. Otherwise, we'll just log the error itself. Okay, so that is it for listing. Now let's write the function for ending. So let's say async function end. Okay, again, await get access. And we're going to grab our ID. So const ID is equal to document.get element by ID. And this is going to be listing ID end. I'll probably have to double check these afterwards, but I think this is what they are. Then I'm going to say await auction contract dot end, and I'm going to call this on this ID. Then we can actually just copy this here and paste this. Okay, so that is it for end. Now we want to have a bid function. So async function bid await get access. We need to grab our ID as well as our value. So I can actually just copy this here rather than typing it out a bunch of times. And rather than listing ID end, this is going to be listing ID bid. Okay. And then for our value, which is the amount that we want to send, I can actually call this amount. I think, what do we call this? The bid amount. Okay. And then we're going to say await auction contract dot bid. We're going to bid on this ID, and the value we're going to send is the amount. Okay, then I'll just copy this. I know this is repetitive, but it's fine. It's going to make it quick for us. And now we have the bid function done. Next, we need to do the approve function. So we're going to say async function approve. And again, we're going to say await get access. Let's grab our ID again. Okay, so const ID is equal to document.get element by ID, listing ID, and then actually this is not listing ID, this is token ID dot approve or dash approve. And now we need to use the NFT contract to approve the auction contract to transfer our NFT. So I'm going to say wait NFT contract dot approve. And this is going to be with the auction contract.address, which will really just be the auction address, and then the ID. Okay, then again, we will copy this and paste this here. Okay, so that will approve the transfer. Next, I'm going to write my withdraw function. I'm going to say async function withdraw. Now again, I'm going to await my get access. There's no information I need to grab here. I can just directly call the function. So I'm going to await auction contract, and then it's going to be dot withdraw. And I believe we called this withdraw funds actually. So let's do that. And then again, we will copy this and paste it here. And we are almost done. The last thing we need to do is actually write the view function, which gives us information, about our listing. So I'm going to say async function view. Okay. Again, await get access. And now we're going to grab the ID that we want to view. So let's just copy one of these here, paste this in, and change this to say view. Now we're going to say const result is equal to await auction contract dot get listing ID. And then we're going to have a dot catch here. And again, we'll just put the dot catch. We don't actually need anything for the dot then, because we will just kind of parse the result out down here. So I'm going to say if not result, then return in case for some reason this listing ID doesn't exist. Otherwise, I'm going to write the information from my result. So the NFT address, the NFT ID, the minimum price, all of that kind of stuff that we're getting into the appropriate fields on our DOM. Now, what did I just do here? Let's go back there. Recall that we have kind of all these fields here that we're going to use: contract address, NFT ID, current bid, etc. So let's do that here. We're going to say document.get element by ID. The first one is going to be the contract address. Dot inner HTML is equal to the result at index 0, which is going to be the contract address. Next, we are going to get the NFT ID. This will be at result index 1. Next, we are going to get the current bid at index 2. Next, we are going to get the min price view, and this is index 3. And then I believe the last one we have here is the end time view, which will be at index 4. Now, this is going to be a Unix timestamp, and I'm actually going to show you how we convert this Unix timestamp into a localized date object. The way we can do that is we can say new date, and then we can actually multiply this value by 1000. But first, I need to convert it to a number. So toNumber multiplied by 1000, and this will actually now show us whatever the local date is for our time zone that corresponds to this Unix timestamp. Okay, I think that is going to complete our JavaScript. I know I just wrote a lot of code there, but that should be all we need for our project to be working. So let me open up my front end now. Let's refresh. Let's open up our terminal. Okay, no issues in the console so far. Let's go to MetaMask. And let's make sure that we are on the account that has an NFT. And I actually just realized, saying this, that we don't have any NFTs, so we're going to have to mint one. So what I'm going to do here, first of all, is just reset this account. So let's go advanced, reset account, and now we're going to mint an NFT so that we're able to actually auction it off. All right, so let's mint this token. The way we can do that is we can open up a new terminal here. Okay, so we have our hard hat node running, and we're just going to type minty mint. Now, for the assets, we can do anything. It doesn't really matter. We just want kind of a sample token to test it out here. So I'm just going to use ./auction.json as like our asset. Then if I hit enter here, it's going to ask me for a name and description. So name, I'm just going to say token, and description, I will say token. All right, it's giving me an error here. It says failed to connect. Okay, so the reason this is happening is we didn't run our IPFS node. So let me run our IPFS node here because that's how Minty is kind of saving this information. So let me open up PowerShell. I'm going to cd into Minty, although it doesn't really matter where I am, and I'm going to type IPFS daemon. Okay, so now that is running. And if I go back here and run this same command, this should hopefully work. So let's go token, and there we go. We have now deployed the token or not deployed, minted the token to our address. Okay, so let's go back here and let's refresh. And now if I open up hard hat, I should see that I have one token. I need to import that token if I want to see it. Okay, so we're just going to trust that I do actually have the one token here. And let's see now if I can approve this token and start using the front end. So let's approve NFT token with ID 1. Gonna hit approve transfer. And okay, it says this is the transaction fee. Give permission to access your one julep. Remember, we just used the default when we deployed our NFT. Okay, so let's go confirm. Success. All right, great. Now that that's working, let's create a listing with this NFT. So I'm going to list token ID 1, minimum price. Let's go with 1,000 Wei and the duration of 1 hour. Okay, so list NFT. Let's make sure this is going to work now and click on confirm. And there you go, success. Now, let me just refresh this and let's view information about our listing. So let me make this full screen. We can go listing with ID 1, view the listing, and we got an issue here. It says revert listing does not exist. It's going to be listing with ID 0. Okay, so let's view that. And now we get information about our listing. Current bid is 0, minimum price is 1,000. It's giving me the end time in my local time zone and telling me the NFT contract address. Okay, now let's change accounts and let's try to make a bid on this listing. So let's go here, change accounts to this one. Okay, just for safety here, I'm going to reset. So settings, advanced, reset account. Okay, let's refresh this. And now let's try to make a bid. So bid on listing, ID 0. And let's see what happens if I bid with a value that's too small. Okay, VM exception while processing transaction. Revert, you must bid at least the minimum price. You can see it's actually giving me that error message. Now let's try to bid the minimum price. Okay, now it's going to pop up MetaMask. Let's confirm this and success. Now if I view listing 0, you can see that if I give this a second here, let's refresh and run it again. Oops, let's pass 0 in here. Then we see the current bid. Okay, it's not been updated yet. I guess this takes a second to update. So let's refresh again, run this, and we should see that the current bid now is updated to 1,000. Great. Now we can go back and we can say make another bid here and see if we can withdraw our funds. So let's go to account 5. Okay, now this is the owner account which actually made the listing, but we can still bid as the owner. Maybe we should have disabled that, but I think that's fine if the owner wants to bid on their own auction. So I'm going to go listing ID 0. I'm going to try to make a bid of 1,000. Okay, notice we have to bid higher than the highest bid. Okay, so let's make this, say, 1,500. Let's make this bid. Okay, confirm, success. Let's refresh. Gonna have to give it a second here and view listing. Okay, let's just keep running this until it updates. Okay, refresh. And it should eventually give us 1,500. And there you go. We can see that now it updates to 1,500. Okay, now let's change our accounts again. Okay, so let's go here. Let's go to account number 3. Refresh. And now let's try to withdraw our funds. So let's just check our balance right now. Our balance is this amount. Okay, 999. And actually, that doesn't look correct to me. Oh, maybe that is correct because it's not showing enough decimals. Ideally, though, once we withdraw our funds, this should go back up to 10,000 hard hat ETH. Okay, so let's withdraw. And we got an issue. It says withdraw funds is not defined. Okay, so let's go back to script here. We probably just misnamed our JavaScript function. And we have withdraw. Let's rename that to withdraw funds. Okay, go back here, refresh, and now let's try to withdraw. Okay, confirm, success. And if we come back here, we should see that, okay, this is pending. So let's wait for that to actually finish. So refresh. Well, actually, I guess refreshing isn't really going to do anything, is it? Okay, it's still pending. I will wait for this to finish. Then I will show you that this ideally will have updated so that we have more funds. Okay, you can see that this updated now. We've actually kind of lost a little bit of ETH. The reason for that is that the gas price that we paid was actually higher than how much we bid. But you can see that it did adjust our balance. All right, so now that we have done that, we have pretty much written everything we need for the auction project. Now, obviously, we can't really test ending the auction yet. And the reason we can't test that is because we have an hour limit for our auction. So if you wanted to test that, I would change the contract to be like 1 minute, 2 minute long for the auction, and then you'd be able to actually test this ending of the auction and transferring that NFT token over. All right, with that said, I think I'm going to start wrapping up this project here. As always, all of this code will be available to download from GitHub, and I hope that this project was helpful to you and showed you how to interact with NFTs, how to use an NFT contract from another contract, and essentially how to set up an NFT auction. With this information, you can go on to create obviously a much more advanced version of this project where you are emitting the different events or kind of showing those on some kind of website. Maybe you show the image associated with an NFT and some of its metadata and all kinds of other stuff. However, with that said, I am going to wrap it up here. I hope you found this helpful, and I look forward to seeing you in another Blockchain Expert video.